Now this Harvard architecture, basically it is relying on the concept of two separate memories for program memory and data memory. All of we know that when we write a program in a computer, we need to give the instructions that are nothing but our program, and another important part is the data on which we are going to operate. So in the traditional computers like which are based on von Neumann architecture, in the single memory both data as well as program is stored. If we see Harvard architecture, it is a type of computer design architecture which has been very much popular over the decades. It is relying on the concept of separate storage of program and separate storage of data. Harvard architecture was first introduced in mid-1950s by Harvard professor Howard Aiken. The idea behind this development of this type of architecture that to have more efficient memory utilization by separating data memory and program memory. One of the important challenge in this type of architecture is designing a processor that can have enough speed and efficiency so as to access it fastly. If we see Harvard architecture, it is the basic type of architecture supporting for parallel access for both program and data memory. So in this type of architecture, we are having separate program and data memory. So as seen in the diagram, that is there are two separate memories, data memory and instruction memory, or alternatively we can call as a program memory. So in this type of architecture, there are separate buses for instructions and data, as compared to that von Neumann architecture with a single memory, and same buses are used for data access as well as instruction access. So because of the separation of program and memory, it is possible to access data and instruction simultaneously by using two separate buses. So basically, Harvard architecture overcomes the problems or bottlenecks in the von Neumann architecture, and it also enhances speed of operation. As there is a parallel access to both instructions and data, it improves performance of the access. And because of this, Harvard architecture is very much suitable for applications where we require high speed processing. Like in case of embedded system, Harvard architecture based processors or controllers are the first priority choice. So if we see advantages of this architecture like fast access of the memory with the help of the separate buses. So Harvard architecture supports for distinct memory spaces for instructions and data. It allows for fixed instruction length. So instructions are of fixed length, and that is going to simplify the instruction fetch process and allows for faster execution. Next important thing about the Harvard architecture is that parallel instruction and data access. Another important feature of this architecture is like more efficient memory usage. So we can optimize the usage of data and instruction memories as per the requirement. We can have the usage. So that's why, because of these important features of Harvard architecture, it is very much suitable for embedded systems, and it is very much critically used in real-time applications. So thank you very much.